Article 310.15b16 provides an exception to the ampacity values listed in Table 310.16 of the National Electrical Code, NEC. Specifically, Table 310.16 does not apply to conductors in raceways, cables, or cords where the conductors are installed in a raceway, cable, or cord that is continuously supported and protected against physical damage. In the situation where number 8 conductors are run in 3/4-inch EMT conduit for a welding outlet, this exception may apply. The key factor is whether the 3/4-inch EMT is considered continuously supported and protected against physical damage. If the EMT is installed in a manner that meets these criteria, then the ampacity limitations of Table 310.16 do not strictly apply. It is imperative to understand the definition of continuously supported and protected against physical damage. Typically, this refers to an installation where the EMT is securely fastened to a structure at appropriate intervals, minimizing the risk of physical harm to the conduit and its enclosed conductors. The interpretation of this requirement can vary depending on local jurisdictions and the specific circumstances of the installation. Therefore, consulting with a local electrical inspector is crucial to ensure compliance. If the 3/4-inch EMT is deemed to be continuously supported and protected, the number 8 conductors may be acceptable for a 60 amp circuit, despite Table 310.16 suggesting otherwise. However, other factors must also be considered. Firstly, the equipment grounding conductor size must be adequate for a 60 amp circuit. Refer to NEC Table 250.122 to determine the appropriate size of the equipment grounding conductor based on the overcurrent protective device rating. Secondly, voltage drop calculations must be performed to ensure that the voltage at the welding outlet does not fall below acceptable limits under load. Excessive voltage drop can impair the performance of the welding equipment and may violate NEC requirements. Thirdly, the termination temperature ratings of the conductors and equipment must be compatible. The conductors must be rated for at least 75 degrees Celsius, and the terminals of the breakers and welding receptacle must also be rated for at least 75 degrees Celsius. Using conductors or equipment with lower temperature ratings can lead to overheating and potential fire hazards. Fourthly, the overcurrent protection at both the main panel and the 6-space box must be properly coordinated. A 60 amp breaker at the main panel should be coordinated with the 60 amp breaker at the 6-space box to ensure that the downstream breaker trips before the upstream breaker in the event of an overcurrent. This coordination helps to prevent unnecessary outages and minimizes the risk of damage to the electrical system. Fifthly, it is important to verify that the welding receptacle is properly rated for the intended welding equipment. The receptacle must have an amperage and voltage rating that is equal to or greater than the requirements of the welding machine. Using an undersized receptacle can lead to overheating and potential fire hazards. In addition to these considerations, it is always advisable to consult with a qualified electrical engineer or inspector to ensure that the welding circuit meets all applicable code requirements and safety standards. Electrical codes and standards can be complex and may vary depending on the jurisdiction. A qualified professional can provide guidance and ensure that the installation is performed correctly and safely. In summary, while Article 310.15b16 provides an exception to Table 310.16, allowing for smaller conductors in certain situations, several other factors must be considered when designing and installing a welding circuit. These factors include equipment grounding conductor size, voltage drop, termination temperature ratings, overcurrent protection coordination, and receptacle rating. Consulting with a qualified electrical professional is always recommended to ensure compliance and safety. The NEC provides specific guidelines for conductor ampacity, which is the maximum current a conductor can carry continuously without exceeding its temperature rating. Table 310.16 is a crucial reference, but it is essential to understand its limitations and exceptions. The exception provided by Article 310.15b16 recognizes that conductors installed in raceways, cables, or cords that are continuously supported and protected against physical damage may be allowed to carry higher currents than those specified in Table 310.16. This exception is based on the principle that the raceway or cable provides additional protection against overheating and physical damage, allowing for higher conductor ampacity. To apply this exception correctly, one must carefully evaluate whether the raceway, cable, or cord is indeed continuously supported and protected against physical damage. This typically means that the raceway or cable is securely fastened to a structure at frequent intervals and is not exposed to excessive mechanical stress, vibration, or environmental conditions that could compromise its integrity. Local electrical inspectors have the final say in determining whether an installation meets these criteria, and their interpretations may vary. The size of the equipment grounding conductor, EG, is another critical aspect of electrical safety. The EGC provides a low impedance path for fault current to return to the source, allowing the overcurrent protective device to quickly trip and energize the circuit. NEC Table 250.122 provides the minimum size requirements for EGC based on the rating of the overcurrent protective device. For a 60 amp circuit, Table 250.122 typically requires a number 10 copper EGC or a number 8 aluminum EGC. However, it is essential to consult the specific table in the NEC to ensure compliance with the latest requirements. Voltage drop is another important consideration, particularly in long circuit runs. Voltage drop occurs when the voltage at the load is lower than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction, reduce its efficiency, and potentially damage it. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To calculate voltage drop, one must consider the length of the circuit, the conductor size, the conductor material, and the amount of current flowing through the circuit. Online voltage drop calculators and NEC Annex C can be helpful in performing these calculations. Determination temperature ratings of conductors and equipment are also crucial for safe and reliable operation. Conductors and equipment are designed to operate within specific temperature limits, and exceeding these limits can lead to overheating, insulation breakdown, and potential fire hazard. The NEC requires that conductors be terminated in equipment that is rated for the conductor's temperature rating. For example, if a conductor is rated for 75 degrees Celsius, it must be terminated in equipment that is also rated for 75 degrees Celsius or higher. Breakers and other electrical equipment typically have temperature ratings marked on them. The overcurrent protection at both the main panel and the 6-space box must be properly coordinated to ensure selective tripping. Selective tripping means that the overcurrent protective device closest to the fault trips first, minimizing the impact on the rest of the electrical system. This is achieved by using overcurrent protective devices with different time current characteristics. For example, a 60 amp breaker at the main panel may have a slower time current characteristic than a 60 amp breaker at the 6-space box. This ensures that the 6-space box breaker trips before the main panel breaker in the event of an overcurrent. Proper coordination can prevent unnecessary outages and protect equipment from damage. The welding receptacle must be properly rated for the intended welding equipment. Welding equipment typically requires receptacles with specific amperage and voltage ratings. Using an undersized receptacle can cause overheating, arcing, and potential fire hazards. The receptacle must be rated for at least the maximum current and voltage requirements of the welding equipment. It is also important to ensure that the receptacle is properly grounded. Consulting with a qualified electrical engineer or inspector is always recommended to ensure that the welding circuit meets all applicable code requirements and safety standards. Electrical codes and standards can be complex and may vary depending on the jurisdiction. A qualified professional can provide guidance and ensure that the installation is performed correctly and safely. Firstly, always prioritize safety when working with electricity. Secondly, never work on live circuits. Always de-energize the circuit and verify that it is de-energized before working on it. Thirdly, use appropriate personal protective equipment, PPE, such as safety glasses, gloves, and insulated tools. Fourthly, follow all applicable codes and standards. Fifthly, if you are not qualified to perform electrical work, hire a qualified electrician. Sixthly, obtain the necessary permits and inspections. Seventhly, keep accurate records of all electrical work performed. Eighthly, educate yourself on electrical safety and best practices. Ninthly, regularly inspect your electrical system for any signs of damage or wear. Tenthly, address any electrical problems promptly. The conductors must be suitable for the application with respect to type, size, and insulation. Voltage drop must be considered and be within acceptable limits. The means of physical protection must be adequate. The wiring must be installed in a neat and workmanlike manner. All applicable codes and standards must be followed. Firstly, the selection and installation of electrical equipment and wiring must comply with the NEC and any applicable local codes. Secondly, the NEC provides detailed requirements for conductor ampacity, overcurrent protection, grounding, and wiring methods. Thirdly, local codes may impose additional requirements or restrictions. Fourthly, it is essential to consult with the local electrical inspector to ensure compliance with all applicable codes and standards. Fifthly, electrical work must be performed by qualified individuals with the necessary training and experience. Sixthly, permits and inspections may be required for electrical installations. Seventhly, proper documentation of electrical work is essential for future reference and maintenance. Eighthly, electrical safety is paramount, and all necessary precautions must be taken to prevent electrical shock, fire, and other hazards. Ninthly, regular maintenance and inspection of electrical systems are crucial for ensuring their continued safety and reliability. Tenthly, electrical systems should be upgraded or replaced as needed to meet changing demands and to comply with evolving codes and standards.